Part 1 of rational number, we have already discussed rational number, number line, representing number on number line, and finding rational number between two numbers. We have already discussed all this part in part 1. So let's recap of part 1. If we have to find two rational number between 2 and 4, then we just simply add both rational number and divide them by 2, that is 6 upon 2, that is 3. If one of the rational number is negative, then we also do the same, minus 2 plus 3 divided by 2, that is 1 upon 2. That's our required rational number. But what if 10 rational number is asked? This type of question is asked in two formats. First format, that number itself contain more than required rational number. Here more than 10 numbers is itself contained between these two rational number. Let's see how. Minus 20, we can write minus 20 as minus 20 upon 1. Okay. 30, here we write 30 as 30 upon 1. We have already studied a number line, so we knew that minus 20 upon 1, minus 19 upon 1, minus 18 upon 1, dot 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 dot, 0 upon 1, dot 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 dot, 13 upon 1, 14 upon 1, 15 upon 1, dot 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 dot, 29 upon 1. These many rational numbers are between these two numbers. How we derive? We derive using number line that we already studied, that in the right hand side all positive numbers and in the left hand side all the negative numbers. But what if asked rational number does not lie between the two given rational numbers? In this case, we simply convert the fraction. We already told you, if do not know the concept of fraction, please just comment fraction in comment box, so we find a separate video for fraction and all the rules of the fraction. So we already knew that if we divide and multiply the fraction with same number, then the fraction does not change. So in this case, we have to find 20 rational number, so we divide first number with 20 and also multiply first number with 20. So we have 20 upon 40. In second number, we have to keep the denominator same. So for keeping denominator same, we have to multiply with 8 and divide with 8. 8 4 32 upon 40. Now we have find how many rational number we have. So we have only 12 rational number between them, or let's say only 11 rational number between them, that is 21, 22, dot 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 32. So in this case, we have to find 20 rational number. So again we multiply both number with 2 upon 2. Now we have 40 upon 80 and second number 64 upon 80. Now we have more than 20 rational number between them. We just simply write them like 41 upon 80, 42 upon 80, 43 upon 80, dot 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 dot, 60 upon 80. Now what if the rational number asked lies between one negative number and one positive number? In this case, we simply just do the similar thing. We write minus 5 upon 2, we write 4 upon 3. First, we multiply and divide first number with the denominator of second number and second number with denominator of first number. So it's become minus 15 upon 6 and it becomes 8 upon 6. Now we check how many rational number between them. So here we have 7 number plus 1 0 upon 6 plus 14 rational number here. So we have a total of 22 rational number, but we have to find only 12 rational number. So we can simply write this 12 rational number as like minus 15 upon 6 or 8 upon 6. We can write minus 14 upon 6, minus 13 upon 6, minus 12 upon 6, minus 11 upon 6, dot 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 dot. Now we move to the decimal part of rational number. Before starting this part, we have to clear a little bit of our decimal basics. Like 2 upon 10, we can simply write it as 0.2. 5 upon 100, we can simply write it as 0.05. How this will happen? Let's see here. Any number in the numerator, and when denominator has multiple of 10, then we can write it in decimal form. First we write down numerator as it is, then how many zeros in the denominator? There is 2 zeros, so we place decimal after 2 digit, 2 digit 2 0. Here 1 0, so we put decimal after 1 digit. If it is said that 625 upon 1000, here 3 zeros, So we put decimal after 3 digit. Okay, just do opposite. First write number as it is. How many digit after point? Oh, there is one digit after point, so we put 10. There is two digit, so we write the number as it is and put two zeros. There is three digit, so we write number as it is and put three zeros. Now let us solve some division, like 2 dividing 33. So 33 upon 2 is 16.5. Okay, but in the case of 20 divided by 3, we put 3 times of 6, 18, to put a decimal, then we carry a 0, then we again divide 3 times of 6, 18, 2, we already had a decimal, so it's again give 20. Again we put 6, again 18, again 2, again 0, 20, and it's carries so on so forth. So we can write 20 upon 3 is equal to 6.666666666 dot, or simply we can write it as 6.6 recurring. This number is known as repeating decimal or recurring decimal. This is known as non-recurring decimal. Non-recurring decimal. We understand these things. Here in the case of 15 divided by 5, we simply divide 15 by 5 by 3 times. 3 times 15. So we can simply write it as 3. It is a non-repeating or non-recurring decimal. Let's move forward. 100 divided by 3. Answer in comment box whether it is recurring or non-recurring. Now solve the recurring type of problem. So we already see in the case of 20 divided by 3, then we have 6.66666. So we simply write it as 6.6 recurring or 6 bar. So this bar represent the infinity times. For example, here write the number as it is 2.3. Bar is on 3. Bar is on 3, so we repeat 3 dot. Here in second question, write the number as it is 4.99. How many numbers have bar? Last two digit have bar. So we repeat last two digit 99, 99, 99, 99 dot. In the case of third one, write the number as it is 5.672. Which number has bar? Number 2 has bar. So we repeat only number 2. 2 dot. Here, write the number as it is. How many number have bar? Only two number have bar, that is 5 3. So drop your answer in comment box. We have to remember one thing, that a rational number can be both recurring or non-recurring. Like 1.6 is also a rational number and 1.6 recurring is also a rational number. So this is our last concept of rational number, in which we change recurring decimal into rational number. Rational number means in the form of p upon q, where p and q are integer and q does not equal to 0. So let's take question number first. Here we assume let y is equal to 0.1 recurring. We can write it as y is equal to 0.11111 dot. Now we have to check how many digit are recurring. So here only one digit had recurring. So we multiply both sides by 10. Now we have 10y and 1.11111 dot. This is our first equation. This is our second equation. Now we subtract first equation from second equation. So we have subtracting 10y minus y is equal to 1.11111 dot minus 0.111111 dot. So here I have 1, here we have 9y. Now we have to divide both side by 9. So we have 9y upon 9 is equal to 1 upon 9. So here we have y is equal to 1 upon 9. And what is y? Y is equal to 0.1 recurring. So we simply said that 0.1 recurring is equal to 1 upon 9. Let's take question number 3rd, 0.6 recurring. Question number 3rd, 0.6 recurring. We assume y is equal to 0.66666 dot. This is our first equation. Now how many digit are recurring? Only one digit recurring. So we multiply with 10. If two digit, then there must be 2 zeros, so we multiply by 100. If 3 digit, then there must be 3 zeros, so we multiply by 1000. Here 1 digit, so multiply by 10. It's become 10y and this becomes 6.6666 dot. This is our second equation. We subtract first from second. 10y minus y is equal to 6.6666 0.6666. We have 9y is equal to 6 9. So we have 9y upon 9 is equal to 6 upon 9. 3 2 times 6, 3 times 9. So y is equal to 2 upon 3. And what is y? Y is equal to 0.6 reckoning. So we say that 0.6 reckoning is equal to 2 upon 3. Now we check, is it true or not? So it's become 0.6 reckoning. So our answer will be right. So 0.1 reckoning value is 1 upon 9. 0.6 reckoning value is 2 upon 3. And you have to find 0.2 reckoning. So comment your answer in comment box. Now what if question asks for like something, this is 2.439 recurring. I don't know whether this type of equation is possible or not. Let's solve. So first we take y is equal to 2.439 recurring. Now we have to multiply both side by 10. So we have 10y is equal to 24.39393939 dot. Now we multiply both side with 100. Now we have 1000y is equal to 2439 dot 39393939 dot. This is our first equation, this is our second equation. When we multiply, when we subtract first equation from second equation, then we have 990y is equal to 2439 minus 24945 then we have 2415. Therefore we divide both sides by 990. We remain with y is equal to 2415 upon 990. 415 divided by 9. 2.439393939. Hence proved our equation is correct. So keep a big smile. You completed your rational number whole part. Now in the next series we discuss some basic rules of irrational numbers, which is around of 5 to 10 minutes of lecture. After that we move to the exponent part. So keep learning.